The apple is the size of a walnut when the egg hatches on its skin. What comes out is barely visible. A pale larva, shorter than an eyelash, and it does not eat the leaf beneath it. It walks the curve of the fruit, tests the surface, and starts cutting at the calyx end, where the skin is thinnest and folded. Within an hour, it is under the surface. It does not stay in the flesh. It drives inward, straight for the core, because the seeds are what it came for, and it will eat them and nothing else if it can reach them. Behind it, a narrow tunnel fills with wet frass, and a small dark ring appears on the skin of a fruit that looks, from a meter away, entirely fine. The tree has no answer for a wound in that place. It seals what it can, laying down corky tissue in the flesh around the tunnel and hardening the walls, and the larva simply eats through it. It drops fruit. Whole apples abscise early and fall into the grass, taking the larvae inside with them. And the larvae crawl out of the fallen fruit and climb back up the trunk. The seeds are gone in 3 days. The core turns brown and wet, and rot organisms move in behind the tunnel and spread outward through flesh that had 4 more months of ripening left. Then the second generation hatches. Each female lays 50 eggs, spread one to a fruit, across the whole tree. But the moth refuses to leave. Finally, the rain arrives, and it brings something down off the bark. Last summer, a larva died on this tree, in a crack of the trunk. And what killed it left behind billions of crystals so small that 10,000 of them would fit across an apple seed. Each crystal is a protein box, and inside every box is a virus. They have lain in the bark furrows for a year, waterproof, shielded from sunlight, completely inert. The rain washes them down the branches and onto the fruit, where they settle in the calyx folds and around the stem in exactly the places a new larva will bite first. The larva hatches, walks the skin, and starts cutting at the calyx. It swallows the crystals with its first mouthfuls. In the gut, everything changes. A caterpillar's midgut is strongly alkaline, more so than almost any other animal's, and the protein box that survived a winter of frost and a summer of ultraviolet light dissolves in it within minutes. The virus is released directly against the gut wall. It enters the cells lining the intestine, copies itself, breaks out into the body cavity, and begins infecting everything: fat body, muscle, blood cells, skin. The larva keeps boring for 2 more days and then stops. It does not curl up and it does not fall. It climbs, driven upward by the infection, until it is on the outside of the fruit or the leaf above it, and there it stays. Color goes first, from cream to a dull milky white, then to a glossy pallor that is not any color a living caterpillar has. Then the body wall gives way. The larva does not decompose so much as dissolve. Collapsing into a white fluid that runs down the fruit below it. And every drop of that fluid is full of new protein boxes. Waiting on the skin of the next apple. The tunneling stops. Apples that were never entered keep going, hanging heavier week by week, their skins pulling color down from the sun-facing side. The corky scars where old attacks were sealed stay as small brown rings. And the flesh behind them is sound. The tree stops shedding fruit. Leaves hold their green into September. Sugar climbs, acid drops, the seeds inside the untouched cores go from white to hard brown, and the fruit reaches the weight where a single touch will take it off the branch. In the grass beneath, the fallen apples of June have long since rotted into the soil. For the apple tree, seeds that reach brown are the entire purpose of the fruit, and everything sweet about it is advertising. For the virus, a caterpillar is a factory, and the last thing it makes it do is climb somewhere high enough to rain on the next generation. For the orchard, one dissolved larva can seed a whole tree for the following year. Nothing here defended anything. The tree did not fight, and the virus did not hunt. It simply waited on the bark for a year, in the exact place the first bite would be taken. In nature's quiet battles, the deadliest things are usually the ones that do not move.